Good evening. Welcome to part two, then the last part of linear equations and functions. So this is the continuation of what we started last time when we met. I'm going to recap um, on the slope or gradient of the straight line graph. I know that I've covered this during our last lesson. So starting with the slope a gradient. So a slope of a straight line is in a graph can be calculated from any 2 points that are selected on that line. Like for instance, as you can see there on that picture that you see that if there are 2 points, you can see that there's points on the left side there, x1 and y1, and on the point B is x2 and y2. So you are able to calculate what the gradient or the slope. And last time when we met, I indicated that when you describe the points, you must know that the first point represent the x value, and the second point represent what the y value. That's how it is. You cannot swap them around. So the formula to calculate that gradient or the slope is given by y2 minus y1 divided by x2 divided by what by x1, which just means that the change in y divided by the change in what x values or x points. So we also touched on the characteristics of the straight line. So we also touched on the characteristics of the gradient, which are important, especially when you are be responding to the exam questions. That when the slope of a linear function like is possible. So in other words, when the gradient, that value of the gradient is positive or is greater than what 0, the line is so we say that the moving is like the line will be moving in an uphill direction across the coordinates axis, and we refer to that one as what that line or that graph is what is an increasing one, or is an what is an ascending line. Whereas when a decreasing linear function is one whose slope is what is negative. So if you find that the value of the slope or the gradient is negative, you should know that what you are going to get there, you're going to get what a decreasing linear what function. So it should just be going down, start up, then going down. It's like a downhill direction across what the axis. So which mathematically is that for a linear function f of x equals to bx plus a, where b is the slope and a is where the graph cuts the y axis, and if b is more than 0, greater than 0, then that function is what is an increasing function. Again, if that function is the way b or that slope is less than 0, we were expecting what any decreasing what function. Whereas the linear function, if f of x where b is equals to 0, so it means that we will have what a constant function, because that graph is just going to cut the y-axis as is represented by the third picture on the slide there. Again, another characteristics of those straight lines that you also need to be aware of is that if two non-vertical lines or vertical functions are said to be parallel, or they're just running like the way that you can see on the first picture there, so we call them that they're what? Okay, they're parallel. So meaning that if you calculate their gradient, you find that their gradient will be what? Will be the same. So it means that those lines will never meet each other. They'll just be running what? Parallel. So that will be the conclusion. So, but if two vertical lines in the same plane intersect at a right angle, then we say that they are perpendicular. And then their gradient, if let's say we were to respond in terms of the gradient, they are opposite to each other. So they are reciprocal. So if the other one, the gradient is -1, so the other one will be what? +1. Okay, we did this activity calculate the slope or that cuts across these points that are given here. And this was the solutions to those activities from the previous slides. Okay, we went through this exercise by just replacing in that formula the values that are here. In fact, we first identify to say -1, this like is an x1, -2 is y1, 3 is y1, if no, 3 is x2, and then 4 is what, y2. The same with the second one and the third one. Then you get those what, those values that we have. So now today our focus is on the finding the equation of a line. So how do we find the equation of a line given a point? So to find the equation of a line, when only one point, let's say x1 and y1, or a slope b is given, maybe let me say, and a slope b is given, because if now we say or, so it means we're just saying we can even work it out even if we got x1 and y1, which is not going to be right. And a slope b is given, use the point slope form of a linear equation formula. Y minus y1 equals to b into x minus x1, where b, because it's not m, okay, where b is the slope of the line and x1 and y1 is a point on the what, on the line. So it means those will be just a point that will be chosen on the what, on the line. So it means you will use this this formula. We'll see when we do the activity on how can we apply this formula. So now if you replace the slope b with its formula, the above formula can be modified as to determine the equation of a straight line in a given 2 points, x1, y1, x2, and y2. So what they are saying is that from the formula that we have here, let me see what's happening here with this formula. Said y minus y1 equals to b over x minus x1. What's happening here? I think here we're trying to derive that formula to say if I've got 2 points, how can we get how can we calculate that that equation? Let's see, because I see that it's kind of confusing. What are they trying to do here? Okay, 1 minus 1. All right, I can see. So what happened here is that we're trying to derive that equation from here, from this one. Let me take it from this equation that we have here, or the formula that we have. This is what is happening. We are saying that we've got this y minus y1 equals to b into x minus x1. All right. So now we want to replace, if we, by now you know that b is, which is the slope, is equals to y2 minus y1 divided by what, x1 minus x2. So that is basically what is going to happen here. So here in this derivation, I know that is not important. So I think here what they were trying to do, because they wanted to show you that what would be like to make this be the shape of the formula here. So you can see that this x minus x1 was going to cancel this one. So it means from this step here, they divided both sides by x minus x1, which is this x minus x1, which is on the left and also on the right. So the next step here is going to be x minus x1 and we have y minus y1, which is going to be equals to what, b, because x minus x1 and x minus x1 is going to what, to cancel. So the next step will be, now that we know that b is the same as this b above there, we know that is the same as y2 minus y1 then divide by x2 minus x1. So this is another formula that you can use to calculate the equation of the straight line. If you are given 2 points, you can use this one, or you can use this one. Then we'll see which one, or how can we calculate other values. Let's look at this activity that we have. All right, the first one says, find the equation of the line that passes through the points -1, 2, and 2 and what? 2 and 1. Yes, we've got these 2 points. And then the second, okay, let's see how far we can go. Let me take this space here. So suppose we have something like this. Find the equation of the line that passes through the points -1, 2, and 2 and 1. So there are two ways that I know of that you can find the equation for this. Okay, maybe I can ask, what do you think we must do here? So we've got these 2 points. Let's say option 1. Option 1, I can first find the gradient or the slope, right? With these 2 points, I'm going to the formula to find the gradient or the slope is given as this. It's y2 minus y1 then we have x2 minus x1. Okay. Then we find the value. So what would be the value for what would be y2? I have y2 is going to be 1, and then y1 is going to be 2 from the values that I have, and x2 is going to be 2. The x1 is -1. Then what will happen will be 1 minus 2, I'm getting -1. 2 minus into -1, so it means negative is going to multiply negative, going to be positive, so it means I'm getting 3, of which the answer is going to be negative what? 3. This is what I'm getting. Okay. So now we have this value. We can use this formula. All right. So we can substitute the values for us to derive that equation from what we have here. So now we'll say, just want to type. We have y minus, so it means y1. We take that first point of -1 and 2, and then of which y1 there's what is 2 equals to, then b, the value of b is what? -3. Then open brackets. We have the value of we have x minus x1 which is minus 1, then close bracket and close again, such that our equation is going to be y minus 2 equals to, then negative 3 multiplied by x is going to be negative 3x. Then, okay, inside there is going to be negative and negative. Okay, well, then let's do step by step. X, negative times negative 1 is going to be plus what? Plus 1. So the next step here, I'm going to take these two to the other side. Side that we're going to remain on the left, we're going to remain with y equals to, then I'm removing the brackets on the right. Negative 3 multiplied by x is going to be negative what? 3x, and negative 3 multiplied by positive 1 is going to be positive 3, and then we say plus 2, which is coming from the left. So the final equation that we're going to have here is going to be y equals to minus 3x plus what? Plus 5. All right, so that's how you find the equation with those 2 points that you have. So another way, let me just say, oh, we can just use this equation that we have here, but you will decide. Just remove this other part. So what happened is just you decide to replace all the values like inside this, because the first one we first calculated what the slope to be minus 3. From there we use that that first formula. We replace the values up until we get that one. So now this one we work it out like everything at once. So then this one, the mathematicians might like this one than the first one. Okay, now the value of y1 from the equation is going to be 2. I'm replacing the values here. Then x1 is going to be negative 1. Okay, then we're coming this side. We have y2. Y2 we have 2, and y1 we have minus 1. Okay, then x2 we have 1. No, what's happening? X2 is 2. Oh, there's something wrong here. Why didn't you tell me? Yes. Can you see where there's something wrong? I was just going to make this equation wrong. Okay. All right, it's fine. I don't. Am I? I'm here. Look here. Y2 minus y1. Yes, y2 is what? Y2 is 1, and y1 is 2. Yes, and x2 is 2 minus x1 is minus 1. I want to change something. Let me finish this one. Oh, okay, it's going down. So such that what we're going to get here, okay, below we're going to have x minus negative times negative 1 is going to be positive 1, and then the numerator is going to be y minus 2, which is going to be, okay, below here 2 negative and negative going to be positive. It's going to be 3. On top, there's 1 minus 2 is going to be negative 1. So this is going to be like this. Okay. What can we do now? So now with this, we can cross multiply. You can see that it's just getting complicated. So I said this one is for the mathematician. Okay, so we can say, because we're cross multiplying here, let's multiply 3. Okay, this is going to happen. 3 into y minus 2 equals to the other one will multiply it by negative 1. Negative 1 into x plus what? Plus 1. Such that, again, we can divide both sides by what? By 3 before we can even try to remove the brackets. Okay, I'm dividing by 3 here, so that is y minus 2, which is going to be, even this side, we divide both sides by 3. It's going to be 3. You have got negative into x plus 1. So if we cancel 3 by 3, I don't have a space here. So we cancel 3, we cancel out, then we'll be left with y minus 2 equals to, here there is 1 here, invincible 1, such that now this one we can still remove the brackets of this minus 1, or you can write it the way out is like, you can write it like this. I'm saying is 3, is 1, is minus 1 over 3. So if you remove the bracket, it's going to be like negative 1 over 3x, then minus 1 over 3. 1 over 3. Say that now, taking the, it's very long, it's just taking too much of my time now. Y, then you take 2 to the other side, then here we're going to have, yes, 3, yes, 1, x, we have got minus 1 over 3, 1 over 3. Then you take that 2 to the other side, we get this. What would be negative, or 2 minus 1 over 3, negative 1 over 3 plus 2? Can you help me, those with a Casio that can just, you can just key in those values, then get the answer. X. What would be minus 1 over 3 plus 2? Okay, it's positive 5 over 3. All right, it's 5 over 3. So it means your straight line is going to cut the y on the far, what, that 5 over 3, I think, which is like what, 1.67 something. Okay, so now going back here, I made a mistake when we were calculating the value, the gradient here, because here is saying what is minus 3, it's wrong. So it's like we flipped the values here. It's supposed to be, I don't know if you're able to see this now. All right, so I'm changing here. Ne? It's not supposed to be this. It's y, too small. It's y2, y1. Then this one is going to be x, and even is going to be what? X. The value C is going to be 1, and then minus 2, and then below here, y, okay, x2 is 2, something, okay, and x1 is minus what? Minus 1, which is going to give us minus 1 here. 2 plus 1 is going to give us 3. So this one, okay, where the final answer, oh, in fact, the final answer is there. It's minus 1 over 3. Yo, so it means I need to correct everything. Okay, so which the value of B is going to be negative 1 over 3. Okay. One over 3. So we'll replace the values here. So 1 over 3. And there was a mistake also. You guys, you're just allowing me to make this mistake. The negative 1 over 3 again, because you're removing the brackets. 1 over 3 plus 2. Then I was told that is it going to be positive or is it going to be negative 5 over 3? 3, 5. All right, I think it is going to be positive. Yeah, I think now it's better. Let's see this one. Find the equation of the line which passes through the point -4, 2, and the slope is what? Is 5. This one is, I mean, you have got only 1 point. So that you can use this formula to calculate that. Okay, you have the value of B is equals to what? Is equals to 5, and the value then x1, you know, it's what? It's minus. Okay, y1 is 2, and x1 is what? It's minus 4. Okay, so let's substitute the values, and then we get our answer. Okay, we are saying y1 is 2. We're only given these 2 points, and then the value of B, we're told that is 5. We replace by 5. Then the x1, we have negative what? 4. This is how you go about it. So now move to the next step, which is y minus 2, which is equals to 5 into x. Negative times negative 4 is going to be positive what? 4. Then we have y. Then you take this minus 2 to the other side, and it will change the sign. So on the right, we'll remove the brackets. 5 multiplied by x, which is going to be 5x. 5 multiplied by 4, which is going to be 20. Then you add the 2 that are taking it from the left. So we have y equals to 5x plus 22. So this is going to be our new line. Okay. So now determine the equation of straight line that passes through points 2 and -7 and 1 and 6. That I can simplify them. We can use the first method in deriving these equations. From that first method, so it means you must first find what? Find the slope first. That's what the first method talks about. That be such that, so let me copy with that formula so that I may not repeat again. Okay, just copying this formula to get the slope. Okay, so you identify, so it means you need to define which one is y2, which one is y1. So in our case, what is our y2?
6. 6. Y2 is 6.
All right, thank you. It's 6. Okay. Anyone want to be the y1 now?
-7.
It's what, -7, right?
Mm.
All right, thank you. X2.
1.
Okay, thank you. X1.
2.
Thank you. All right, so now on the denominator is 1 minus 2, which is going to be negative what? -1. Okay. Then we've got 6 minus into minus 7, so it means negative and negative are going to be 7. Oh, they're going to be positive. So 6 plus 7 is what is it? 13.
13.
All right, thank you. So the answer is going to be what? -13. So this is according to the calculations that we have. So now with this, so you take this formula and then replace the values to give you the solution. We have that one. Okay. We replace the y1, so it means we choose that point 2 and -7. Y1 is going to be -7. We replace it. Then the value of b was saying is -13 that we have calculated. Then the value of x1 is 2. Okay. Then we remove the brackets stuff. So it means we get y. Negative and -7 is going to be +7 equals to, then on the other side we will have -13 into x minus 2. So we have y, then we'll take 7 to the other side. So on the other side, we'll remove the brackets. -13 by x is going to be -13x. -13 times -12 is going to be positive what, 26. Then minus what, 7. So the final answer, so this equation is going to be y equals -13x plus, what is 26 minus 7? Is it what, 19?
19 is.
All right, thank you. So this is the equation that you will get. Because I mean, this type of question, those are the questions that, I mean, when you leave the exam, you know, you're quite sure that this one you got it right. So yeah, so don't just leave those bonus answers that you have. Okay, the next one, it says a straight line passing through points 3, 2, 0, and 5 is an ascending, or it's a question. Is the straight line passing through the points 3, 2, and 0, and 5 an ascending, horizontal, descending, or vertical? Right? We've got these 2 points. So let's talk. How can we determine if, I mean, we're only given these 2 points, and then we want to find out if this line, because we know that if we're given these 2 points, we can be able to, by now we're able to derive the straight line equation. We know to calculate the slope, which is the gradient, and be able to know, I mean, to identify whether that line, it's an ascending, it's a descending, it's horizontal, it's a vertical, based on the characteristics. All right. So what do you think, if, I mean, we're just talking, what is that maybe we need to do to be able to respond as to whether that straight line is an ascending, horizontal, descending, or vertical? You can say, even if, let's say, you think we need to maybe to first derive that equation, and then, yeah, you can say so. Let's talk. Or maybe we can just respond to say, if the line is it's ascending, maybe and ask why why are we saying it's an ascending? Why are we saying it's an descending? Why are we saying it's a vertical? Why are we saying that it's horizontal? Okay, from Tinswale is saying we simplify and simplify and then draw the graph. Okay. Lucy saying we need to find the slope first. Okay. So if we find the slope first and then what? Let me okay, let me see. Simplify, then draw the graph. That one you want to see. Okay. And as I hear what you're saying. Then Lucy saying we need to find the slope first. I think the easier one is about what? The slope. Do you remember there's a slide that I presented? In fact, when I first presented this, I first by recapping on gradient. All right. So if you look at uh, this slide here, is the one that is talking about the issue of ascending, descending, and stuff like that. So you can see here, okay, the increasing, decreasing. This picture that is here, if maybe in an exam they've showed you, let's say, to say, okay, indicate if, let's say, this kind of graph that's descending, then you can just look descending or ascending or horizontal or whatever, but just looking on the on the picture itself. But in our case, we are given what? The points. Okay, let me go to this other one. Yes. Can you see here where it says a graph is said to be, let me highlight this so that I'm able to understand. A graph is said to be ascending if the value of b is positive. All right. And descending if the value of b is what? Is negative. What is this b? The b is a what? It's a slope. So it means you are able to respond to this question without doing a lot, but by just doing what? Where is it? Oh, by just calculating the slope between these 2 points, and then we get the answer. Okay. What's that formula for the gradient? That value of b is here. Okay. So we have these 2 points. We substitute and see what are we getting. So now let's talk. What is y2 that I can only just type? Okay,
Y2 is 5.
it's 5, and y1.
Y1 is 2.
Thank you. Then we have x2.
It's 0.
Okay, we have x1.
It's 3.
It's 3.
Yes.
Okay, now equals to the 5 minus. Okay, let me do this. Below here we've got 0 minus 3, which is going to be negative 3. Then on top here, 5 minus 2, we are going to get what? Again, this 3. We have 3 divided by minus 3, which is going to be what? Minus 1.
Minus 1.
Yes. Now let's talk. So is the line that we're going to have here an ascending, horizontal, descending, or vertical? Based on the characteristics of the slope. Okay, since B is less than 0, okay, let me say is equals to -1, which is less than 0. Therefore, what? It's a what? Descending. Is it not what is the screen is saying here? Where is it? Yes, if the slope is negative, so it means it's what? It's a descending. I think there is an equation that we need to draw so that you will be able to see what I'm talking about when we plot this graph. That yes, indeed, is what is descending. All right. So is it clear where you apply the issue of descending and ascending? Because you should not find this question and find that they are difficult. Some of the things you don't need to struggle, just need to think, say, oh, okay, now I hear. Can you see that we don't even need to go and draw that that graph, because what you were going to do here, if that take that approach, you're going to derive that equation. After deriving the equation, you draw the line. Now you'll be able to say it's an ascending by what? By seeing that it's an ascending, but by just finding the slope, you're able to determine whether it's an ascending, descending, and stuff like that. See, so that's how it is. All right, the next one, determine whether the two lines are parallel, perpendicular, or either. We were not sure. So we have 3x minus 5y equals to 6, and 6x minus 10y equals to 7. Okay. So what is that we said about the lines that are parallel and perpendicular? Let's start with the parallel one. We can again refer back to that screen that I spoke about there. Everything is here on the slides, colleagues. The parallel lines, as you can see on the screen, they've got what? The same what? Slope. And the perpendicular one, so their slope is what? It's a reciprocal of each other. I even gave an example to say if the other one is -1, the other one is going to be what? The slope of it is going to be +1. So now let's prove if that's true, whether these two lines are parallel or perpendicular. Okay, we are starting with what? So it means it's just talking to the what? To the slope. Okay, let me ask, what is the slope of the first equation, this 3x minus 5y equals to 6? If you're unable to find it here, it's still fine. You can tell me what is that I need to do. What is the slope of the first equation? Or if it's not, if you can't see it, then you can tell me what is that we need to do in order to find that. What would be the gradient of the first um, linear what function? So you should remember that the standard, let me just say standard form of the linear equation. Let's say the standard form of linear equations or linear function, not equation, should be in this form: y equals to bx plus what? Plus a, something like this. I'm used to y equals to mx plus c, but your study guide, I think it gives you something like this. So it means for you to be able to find this slope, which is b, and with this equation that you have here, so it means you must convert this equation that you have here into that what format. So how do we do that? We just need to use what I mean, what do you call it? Simplifying. Okay, we have 3x minus 5y equals to 6. So for it to be y equals to bx plus a format, so what I'm going to do here, let me see. Okay, tell me now. So it means we're going to take, okay, whatever that doesn't have y to the other side. So I'm taking 3x from the left to the right, which will change the sign. Let me first write this 3x here. There it was positive 6. And then now that we have got this minus 5, so I'm going to divide the whole equation by minus 5 so that I can have y alone on the left. So it means, oh, by yes, negative 5, you have got negative 5y is equals to negative 5, and here we've got negative 3, and then there's what? There's x, and here we have, because we are dividing by negative, you can say it's negative 6 over 5, something like this. So on the left, we are going to cancel that minus 5, which we are going to remain with y equals to negative, and negative is going to cancel out, and we will have 3 over 5 here, and minus, oh, there's x here, minus 6 over 5. 6 over 5. So with this, can you see now we have got what? The value of b is going to be what? 3 over 5. So now let's look on the second equation now, because we want to check if these are parallel, they're perpendicular, or whatever, or they're not. So let's take the second one equation again and do the same as we did on the other one. Second equation. Okay. So even this side, our intention is to get, I mean, the y. So it's negative 10y equals to, then I take 6x to the other side. I will get to change the sign to be negative 6x. Then there's what? There's 7. So for me, then to get the y on the left, so I'll need to divide both sides by negative 10, which is going to be this side is negative 10. Yes, negative 6. Oh, by the way, there's x here. Okay, there's x here. Then this side is going to be 7 over 10. 7 over 10. So on the left, negative 10 will cancel out, and then will remain with y equals to the negative and negative are going to cancel out. Then will remain with what? 6 over 10. 6 over 10. Then minus 7 over 10. 7 over 10. So now this equation, I think you can still go further, because this x here that I left out, I don't know why the x doesn't want to go. So now with this 6 out of 10, you can take the common factor of 6 and 10, which is 2, such that this equation, so if you divide 10 divided by 2, we're going to have 5. 6 divided by 2, we're going to have 3. It's going to be x, then minus 7 over 10. 7 over 10, there's no factor here. All right. So we have this. What can we say? Let me say this one. B equals to 3 over 5. 3 over 5. And again here, all right. So now let's talk. Determine whether the two lines are parallel, perpendicular, or either. So what can we say now with what we did? Determine whether the two lines are parallel, perpendicular, or either. So what would be the answer? Okay, I can see Mamsari is saying that is parallel. Yes, they are parallel because look here, what are those lines? If the grinder, the what, the same means that the what they're equal. So it means those lines are going to be what, parallel. They're not going to touch each other. Yes, that's correct, because I've calculated that the value of of b, which is gradient, is what, 3.5. You see, 3/5, not 3.5, and the same for both. And the reason that can you see the reason that I put this equation, for you to be able to see that, you must first derive it to be in this form, so that you're able to see what to be the value of what, of b. The same here, because it's on the standard form. That's how you go about it. Okay. Let me. Okay, this one we're done. Draw the following lines on the graph: x equals to 2, y equals to 4x, and y equals to this another thing. And then the last one, it says a line parallel to 2x plus y plus 1 equals to 0 is which one? And let me see this one. Determine the slope x and y-intercept for each of the following and draw the graph. Okay, maybe I want to skip something here. I'm skipping this first one, right? Then let's look at this one. A line parallel to 2x plus y plus 1 is equals to 0 is which one? So this is like a possible exam question that, like, you find that they just give you to say a parallel line 2x plus y plus 1 equals to 0 is which one, right? Now let's see, by just going through the way how it is. I can see 2x plus y plus 1. So this one, remember, we need to write it in the standard form of straight line graph. Let me see. If it's like this, so that 2x plus y, you can rewrite it as y equals to, you take 2x to the other side, which is going to be 2x, and then you take plus 1 to the other side, which will be what? Y equals to minus 2x minus 1. Then such that the value of b is equals to what? Minus 2. So it means you need to, from these ones that are here, you need to find the equation that has got what? The same slope, which is what? B equals to minus 2. Let's try to analyze the first one. Let's see, those are the options we were just trying to analyze, because I mean, imagine there are 4 options. If you go through the first one, you work it out, then second one up until the 4th one, so time will be running. So let's look at the first one, which is 3x plus 2y plus 1. Do you think the value of b is going to be minus 2? But by just looking into this, I don't think so, because here, if let's say we were to take this 3x to the other side, and then this one the other side, and now is 2. So it means what I'm going to get is, I might get what, that the value of b here might be minus 3. Okay, yes, negative 3/2, which is wrong. The second one, I've got 2x plus 2y plus 1 equals to 0. So in this instance, if I take this 2x to the other side and the 1 to the other side, and then the value of b here, and here I'm having 2y, which I will need to divide by 2, I'm going to get negative 1. Again, the value of b will not be the same. Then the third one I'm getting is 3x plus y plus 1 equals to 0. So if I take 3x to the other side, it's going to be negative 3x, right? Going to be negative 3x minus 1, which also is what? It's wrong, because the value of b is going to be negative 3. And here, for this equation to be parallel, they need to be what? To be the same. So which gives the answer to be what, number 4. So let's see if the fourth one is going to be the right one. Ne? Okay, we have got this equation that we want to test as a possible answer to see if we're going to get the same what, the same gradient. So I'm saying, because now we want to have y on the left, so I'm going to have 2y, and I'm taking the rest to the right. 4x is going to be negative 4x, and then 1 is going to be what, negative 1. So now I'm going to divide both sides by 2 so that I can have y on the what, on the left, such that this side, okay, yes 2, yes negative 4x minus yes 2, yes 1. So 2 and 2 will cancel out, and I will remain with y equals to negative 4 divided by 2 is going to be negative what, 2x minus 1 over 2. All right. So that the value of b is equals to what, negative 2. Can you see that the correct option is what, is D? All right. So this is how you go about it. All right. So that was it in terms of that parallel thing. Now let's see this one. Determine the slope x in x, the y-axis for each of the following equation. Draw in a separate set of x's. We have got y equals to minus 2x plus 3. So you can see that the first equation has got a slope which is negative. So now we can, by drawing that, we can determine if we are going to have, that graph is going to be what, the descending one. The second one, you can see that it's going to be, the value of b is it's more than 0, which is what, 3. So meaning that we are going to get what, an ascending slope, right? So let's see if you're able to draw this graph. Now let's start by find what the intercepts, so that we can see where our graph cuts the x and y intercept, or the y-axis, or the x-axis. Okay, let's say find, okay, to find x what, intercept, let y equals to 0, such that from that equation, where there's y, we replace it by 0, which is going to be minus 2x plus what, plus 3. But then I will take that minus 2 to the left, and I will have 2x equals to 3. And then solving for x, so it means I will need to divide both sides by 2. Here we've got 2, we've got 2x equals to 3 over 2, which x is equals to, what is 3 over 2? It's 1 comma what? I want that comma. 1.5. Okay. So this is going to be this value. So it means this graph is going to cut the axis on 1.5 and what? and 0. Okay, so now the y-intercept, as I've indicated, previously, intercept. So this one that you can just look on the value there. It's like when you let x be equals to 0, so you're going to get, so it's going to cut the y on what 0 and what and 3. Okay, so this is how it's going to be. So now we have got these two points. What we are going to do here, let me see. These are the values that we have. I think they're enough to draw a graph. Let me try to estimate where's this. Smart art. I don't see our shapes. Yes. Okay. So it means in a graph. All right. So these points y-intercept for 0 and 3. It's just a rough sketch that you're able to see. So you must know that, okay, this is a y-axis. So from this point going up here, those values are positive 1. Let me see if I'll be able to see. How can I write now? Like I said, that I'm limited. Can I just just point to say this point 0 and 3? We're just estimating to say, if let's say suppose yes 1, 2, 3, so I can just only concentrate on the values. Like let's say 3 is here. Okay, so this is 3, and the other one is saying is what 1. Oh, I said 1.2 is 1.5, 1.5 and 0. So this point is on the x-axis. So that is going to be somewhere, let's say here. It's 1.5. Okay, so now those are the points. So what is going to happen? Our graph now for the shapes. Yes. Can you see now a line that is going down, showing you that it's a what? It's a descending line. So it will be go down like this. So these points here, it's is that point which is 0 and what, and 3. Okay, whereas this line, this one here, it's 1.5 and what, and 0. So this is how you draw this graph. Okay, so it means now even if let's say in a question it comes being drawn like this, you are can be able to interpret this graph to say, I mean, if let's say they gave you this graph, and okay, they gave you an equation and they said which one maybe, I mean, is it represents the graph that is provided. By just giving you, let's say this will be the first option and give you the other one, you should be in a position to also think about this and the characteristics of the slope to say, okay, this is the one, even if, I mean, you're not going to be asked to draw it in an exam, but they can just present a graph and then an equation to say, can you map the equation that are given with the graph that is provided and give the correct answer. All right, so then the last one, let's see, it's y plus 4 equals to 3x. So you know that this one is going to be rewritten. like this. Y equals to 3x minus what? Minus 4. All right. So to find the value of x, intercept, then we let y equals to 0 such that y equals, oh, it's 0 equals to 3x minus 4. So in this instance, I think like last time said, okay, another one said you can take 4 to this other side, change the sign, then 4 equals to 3x, then you can swap them around. It's still the same, which is 3x equals to 4. Then you divide both sides by 3. So you've got 3, you've got 3x, you've got 4. You divide by 3, you've got 4. Okay. So x equals to 4 over 3. Is it also 1.5? The 1.3. Okay, this is 1.3. So the value of y is going to be what? Minus 4. All right. So the y intercept here, the obviously y intercept, so it's going to be the value 0 and minus 4. So it means going to cut the y on this value 0 and minus 4. So now let's draw this this graph. Okay, insert shape. So for this line, we have the x1. So we're saying it has to cut the axis on what? X-intercept, you said, oh, 1.3 and 0. So it's going to be somewhere okay, somewhere here. Let's say 1.3. At this point, it's 1.3 and 0. And the other one is 0 and negative 4. Okay. Okay, negative what? 4. So just I mean, this happens when x is 0 and y equals to what? Minus 4. So when y equals to minus 4. So now, this are going to draw it. It means it's going to be a straight line that we cut here. Right? So can you see now, this is what? An ascending, because he's going what? Up the hill. Unlike this one that went downhill. So this is how you respond to this kind of equations. Okay. All right. This brings me to the end of linear equations and functions that I've prepared. And I believe that with what we have covered, there's no way that you can get an answer wrong on the linear equations and functions. So as I was preparing for this session, I don't know, you can tell me. I just find this other aspect that I did not touch, which is the percent change. I mean, the problems that deals with what the percentage, and thought like I should include it to tonight's lesson because it's only 2 slides, I think. Let me see. Yes, it's only this slide and then the activity. I mean, in terms of the percent change, because I think there are instances that you can be asked. I mean, in terms of what would be the, I mean, the percent change. If you are given the old value and the current value, to say what was that change. Or maybe if you can think of, let's say you bought a house maybe some years ago, and now you want to sell it. So instead of maybe talking in terms of the monetary value, you can also talk in terms of the percentage to say, okay, from that year to now, what is the percent change? So you can use a formula to calculate the percentage change to see if you have made an investment, a good investment, or not. I mean, just to talk in terms of the percentage. That is an aspect that I thought it also helps you to respond to that. It's just only 2 slides, if you can allow me. All right. Yes, I think I've already given what I want to talk about. That with percent change, here we're talking about the relationship between an old value versus what the new value. Because you're also able to see, we are running on loss. I mean, we can't talk about buying a car some years ago and then now that one, that is going to be what, a percent decrease value. So that percent change is given by this formula to say percent change is equals to the new value minus the old value, all divided by what, old value multiplied by what, by 100. And then it will give you a percent because of that what, 100. So if the number or the number is positive, so it will indicate a percent what increase. So it means, in other words, if you get a positive percent there for using that formula after substituting the values, and you find that it's giving a positive answer, it means that is what there's a percent what increase. Whereas if the answer is negative, so it will indicate what, a percent decrease. But on the possible answer there, it will just you just need to give it in positive, like you can't say it's like a negative, it's a 10%. You can just give the percent. If it asks you to say what would be the percent decrease, you can't again say it's negative 10%. So it means you can just indicate, say the percent decrease here is going to be what, like what, 10%. So that's it that I wanted us to know about that one. So now let's look at this activity, which will be the last for the day and the last for the semester. And this should not take us long. Okay, let's look at the first one. So remove this too. A school had 1,200 learners in 2021. In 2022, the school had 2,000. The percentage increased from 2022 to how? 2022, let's say, to 2023. Yes. Okay. Yes. Yes. Was how much? All right. So you can see that. I mean, you can just say 2,000 minus 1,200. You can see that is 800. So, but we don't want it in numbers. You know that I think the stats is good when you're presenting it in percentage than in actual numbers, because the number might what differ, right? So in this instance, it means you can use the various just look using this very same formula. So the new value from this school, so it means is what, is 2,000, and the old value was 1,200. And the old value was 1,200. So what would be the answer? That answer would be in percent. 2,000 minus 1.2, it's 800. Then if you divide by 1,200, You get something like what? 0.67 multiplied by 100. It's like 67.66 point what? All right, I can see. Thank you. 66.67. Let's say in two decimal places, 67 percent. So this would be the what? That increase from that value in terms of the stats, if they're giving the stats. Okay, that's fine with that one. So John bought a watch for 600. After 6 months, he needed cash and sold it for 450. The percentage loss according to decimal digits is what? So again, let's try this one. Because it's percent loss, which the expectation is that we're going to get a negative value here, because the new value they're saying is 450 and the original value was 600, and even here 600. Okay, what would be the answer? I know that it's going to be negative. Okay, I think it's going to be negative 150. Okay, 150 divided by 600, 0.25 multiplied by 100 is going to be 25%. So it means this is going to be the loss, which is 25%. All right, I think this one is straightforward. Now let's look on this one. Okay, the Department of Public Service and Administration offered an annual increase of 7.5%. If a worker earns 15,000 at this stage, the amount that the worker will earn per month after salary increase will be how much? So I just put it this because I mean this was on the public domain, that the public servants got an increase for 7.5%. So you should be in a position also, if those who are working, or yes, I mean, even if you're just a student, or I think, or there's another question that is talking to the students, that if they say there will be an increase in the, let's say, in the funds, I mean, in the tuition fee, what will be that? You should be in a position to calculate it yourself and estimate, say, okay, what does this mean before they effect it, you see, just to have that kind of estimation. So to do that, so it means you need to have a techniques in terms of how do we do that. Okay, let's look at this one. The Department of Public DPS say annual increase of 7.5%. The workers earn 15% of this. That amount that the worker will earn per month after salary increase is going to be how much? I think this one we don't need to use the formula. What do you call it? The percent change. Because here we need what? Well, how much? What would be that amount? It's getting 15,000, and then we've got 7.5. So it means in this instance, we just need to calculate to find the 7.5% of what? 15,000. Then you add it on top of 15,000. Then you get what? The answer. Am I correct? It's like we're going to say 15,000, right? Plus 7.5. I think the calculator can do this. 7.5% of which is multiplied by what? By 15,000. What would be the answer?
1,125.
Or it's going to be 1,000. The total. You can give me the total now. 15,000 plus 7.5 of 15,000. That's what I'm saying. All right, I'm getting 16,125. So this should be, I mean,
16,125.
all right,
Yeah,
thank
yeah.
you. Oh, yes. Yes. So this is the value that you're going to get. All right, thank you. Let's look at the last one. In 2023, it cost 1,670 to study a semester module in economic and management science at UNISA. If a 9% increase in fees is implemented for 2024, how much more does it cost to study 10 modules in 2024 than in 20 in what What's happening now? That in 2023. Yes. Okay. So this what if I don't know how much are your modules. Likely enough is that when you register for those modules already, it does the calculations for you. But on the other side, if maybe there's an increase before, you can wait for the system to calculate. You can have that kind of estimation to say, oh, okay, how much do you think this can cost? Can I give you this so that you can try it? Because what I can say here, you've got that one. The module was 1,670, right, to study a semester module in that. Then if a 9% increase in fees is implemented for 2024, so it means you can say 1,670, right, plus 9% of that 1,670 is going to be, right, then get a difference of of that of that percentage, then that difference multiplied by 10, it is going to give you how much more does it cost for 10 modules. You have got 1,670, right, to study a semester, okay, semester module. Then if there's a 9% increase, that portion for one module, right, you multiply it by what? By 10. Okay, maybe first find that difference, then you multiply it by 10. Yes, we multiply it by 10. That will be what the more that you will be paying on top of that. So that's what I wanted to say. All right, colleagues, let's call it a day. Let's stop here for tonight. It has been good to be with you throughout the whole semester. Thank you so much for connecting to this class. Yes, so this just bring me to the end of my lesson tonight, and I think the lesson for the semester, unless if you can still meet once more again before you write your exams. Thank you so much. Thank you.
Bye-bye.
Bye-bye.